The first concept that I just want to take a few minutes to review is understanding matter and the different ways that matter can be classified. All of this is probably familiar to you. All of these terms are somewhat familiar to you. However, it's important that we're all on the same page, and because we use these so frequently, it's good that we know what accurate definitions of these words mean. Okay, so starting with matter, all right? Matter is defined as anything that has mass and takes up space, which means has volume, okay? In science, the thing that matter is categorized differently from is usually energy. So in science, specifically in chemistry and physics, we spend a lot of time focusing on matter, but we also spend a lot of time focusing on energy, and those two are completely different. So matter is anything that has mass and has volume. There are two main categories, okay? The first one is a pure substance, and the other one is a mixture. A pure substance can be described two ways. You can either have an element or you can have a compound. So as you guys are familiar with, anything on the periodic table, so like copper, iron, sodium, lead, chlorine, hydrogen, right? All of those substances are classified as elements, and that's why they're on the periodic table. A compound, on the other hand, is a substance that contains more than one element, all right? So like H2O, CO2, NaCl, okay? So anytime you have a substance where there's more than one element symbol in that formula, then you know it's a compound, all right? Just keep in mind, elements are chemically combined to form compounds. And what that means is that chemical bonds form between the elements that make up that compound. And as you know, those bonds are either ionic or they're molecular, and we'll talk about those more later. All right, moving on to mixtures, okay? Mixtures are the other type of matter, and it's important to understand how they're different from substances, okay? The big difference here is the concept of being physically combined. Mixtures are pure substances that have been physically combined, okay? So for example, salt water, okay? Hold on, not doing a very good job of writing here. Okay, salt water is a mixture because, as you know, the salt is typically NaCl and water is H2O, okay? And so that is two substances that have been physically combined, meaning they've been mixed, okay? They've been stirred, they've been shaken, they've been dissolved. In a lot of cases, like nature does this for us. Like the ocean actually mixes these two substances together for us. So that is a mixture because those two substances still retain their separate identities. Okay, and you know that if we had a beaker full of salt water and it was an open container and we just let it sit on a counter for months, even weeks, it wouldn't take very long. Over time, the water would evaporate out of that container and we would be left with salt in the bottom. Okay, that would be a really easy experiment for you to do at home. Mix up a little salt water in a glass, let it sit for a few days, especially if it's humid and you don't have like the air conditioning on. Or even if you do, it doesn't matter. Just let it sit and you'll see that the water evaporates from that container and leaves the salt behind. And that's proof that that is a mixture, because the two substances are separate from one another. They're not combining together into some new formula, okay? There are two types of mixtures. It's important that we understand what these are. The first type is a homogeneous mixture, and the second type is a heterogeneous mixture. We spend a lot of time on homogeneous mixtures because that's how solutions are classified. Okay, aqueous solutions. As you probably know, and I'm sure you've seen the symbol AQ in a balanced equation before. AQ stands for aqueous. Aqueous means dissolved in water, because water is regarded as the universal solvent. Okay, so it's important that we understand the different types of mixtures, especially homogeneous mixtures, because we'll spend so much time focusing on them. All right, the big thing here is, the prefix homo means the same and hetero means different, and that's important, because what that means for mixtures is that for homogeneous mixtures, it means that the mixture is the same everywhere. That means any sample of that mixture you take would be identical to any other sample of that mixture you take. Okay? That means that any substance in that mixture is evenly distributed throughout the entirety of the mixture. All right? Whereas a heterogeneous substance mixture, on the other hand, a heterogeneous mixture is different in different spots. Okay, so you might have some spots that have more of one substance and other spots that have less of that same substance. Okay, and that's really how they're different. So to talk about those for a minute and to give you examples, like I think the best example of a homogeneous mixture is air, right? Because as you know, air is a mixture that contains mostly nitrogen, but then it also has some oxygen. And oxygen is vital for our respiration. So, constantly we're around here, we're living, we're breathing, and no matter where I am and what I do, I never think to myself, oh, am I in the right location to get enough oxygen to breathe right now? Okay, none of us think about that. And the reason that we don't think about that is because air is a homogeneous mixture, which means if you're in a classroom, or if you're at home, or if you're outside, okay, wherever you are, the air that you're breathing, theoretically, every breath you take should be the same as the next breath you take, no matter where you are. Or if you're sitting in a room with people, if we were in class, the example that I would use was like, never when we do a seating chart do you think to yourself, oh, I want to sit in that spot in the corner because that's where the really good oxygen is. No, you know that you're going to get the same amount of oxygen no matter where you're seated in the room, because it's a homogeneous mixture. Now, I'm not saying that there aren't pollutants and stuff that get in our air. There is. But again, part of the way that those pollutants get filtered out is because they become so well distributed in the air that once they've had a chance to really disperse and move throughout the mixture, they're present in much lower numbers than their point of origination. Okay, and that's part of what makes it safe, is the fact that air is always a homogeneous mixture and working to be a homogeneous mixture. So if something new gets in the air, that substance is eventually going to be evenly distributed throughout. Okay, and that's what solutions are, and that's important for you to know. Okay, because we work with a lot of solutions in chemistry. Anytime you see AQ, that means that substance is dissolved in water. Okay, and it's so well dissolved that you can't tell, okay, where's the copper sulfate versus where's the water. Like, it just looks completely the same to you everywhere, and it should look completely the same to you. And not only that, but if you took a sample and you analyzed it under a microscope, it should be exactly the same. Okay, in comparison, I would say a heterogeneous mixture, and I'm just going to use an example like from your kitchen because I think that's probably the easiest. A heterogeneous mixture would be like Italian salad dressing, okay? Where when it's sitting in there, what happens is the oil layer rises to the top, and then at the bottom you have like the vinegar water layer, and then usually most of your spices and things settle the bottom also. So before you use it, typically what happens is you shake it, okay? Or like the example that I hate is, for example, like ketchup. Like, I don't know about you, but it like really grosses me out when I go to squeeze ketchup out of a bottle and that like watery ketchup comes out instead of like the thick ketchup. And part of the reason there is because, again, the mixture separates. And the reason we shake it is to try to make it homogeneous while we're using it. Okay, but when you leave it alone, it naturally separates where there's different regions where like the watery part might be in one area and the thicker stuff might be at the other side. And that's a heterogeneous mixture where not everything is the same everywhere, where you can have specific substances represented in a more concentrated way within different parts of the mixture. Okay. And so that would be an example of heterogeneous. So it would be good for you to just to familiarize yourself with them, make sure you're confident about those. I am going to make a little Schoology quiz available to you for you to practice those, just so you can see how you're doing with those words.